Okay, the unit circle is a very useful concept and very useful construct in for two different ways. Okay, um, one reason it's very useful is because we can use a unit length, and if I want to scale a unit length to, like, for example, so if I have a unit radius, so that's why it's called a unit circle, because it's a radius of 1. If I want to scale this to any size circle, it's quite easy. I can just scale it by whatever multiplier. If I make it 2 centimeters, I multiply everything by 2. So this length by 2, this length by 2. If I make this length 15.8, well, I can just scale everything, make the vertical, multiply whatever that is by 15.8 and multiply that, whatever that is, by 15.8. So as a unit rate is very useful, okay, in that way. However, it's more valuable as relating the sine and cos values to actual lengths and position. It allows us to look at the ratio as actual length in a diagram. And that's very useful because we want to do geometry with lengths. Okay? We want to be able to work out lengths, areas, all those kind of things. And we need lengths to do that. So we're going to use a unit circle in that way. So we're going to make sure we establish what a unit circle is. So here's my unit circle. That's radius 1. In a unit circle, what I'm going to say is that the x length is the same as the cosine ratio. That's a very useful construct to say that that length, that piece of line there, is equivalent to this cosine ratio number, whatever that is. And it's also we're also gonna define it with sine. Okay, so we're gonna say that this vertical length, okay, this vertical line here, the length of that line is the same as the sine ratio. Okay, and that's very useful because now, in standard position, we want to work out positions. I can actually work out my position using a cos ratio and a sine ratio. And not only that, it's not length, it's position, because if I go this way, I have positive cosine. If I go this way, I have negative cosine. If I go up into quadrant 1 and 2, I have positive sine. If I go down into quadrant 3 and 4, I have negative sine. So the cosine and sine not only give me lengths to work with, it also works out position. That's a bonus. So we can start using this to establish some identities. So looking at this right triangle, I can say that, well, cosine theta squared plus sine theta squared, whatever this length is squared, plus this length squared equals 1 squared, which is 1. So we come up with this Pythagorean relationship, and now we're doing geometry, okay? And we're mixing our trig. We're able to use our trig as lengths. And this is a nice thing about the unit circle. Okay, so again, the unit circle has some multiple uses, and one of them is using it as a unit rate. Okay, so if I have a problem here, I have an angle of 1.4, right about there. There's about 1.4 radians, and this is on a circle of radius 3. Okay, so I'm going to say that this is a radius, that line is 3 long. And I want to find the x and y coordinates of that point. Well, I could have done it before with, like, opposite over, hypotenuse, and then solve for the opposite length using some algebra. But I'm going to do this slightly differently. I'm going to just say, I know I have a unit circle. Okay? And there's my unit circle, there's my point there. And if this is a unit circle with radius 1, I know that that point is cosine 1.4, and the y coordinate is sine of 1.4. Okay, whatever that decimal number works out to be. In fact, I'll work it out for you. Cos of 1.4 is 0.999. Do I have it in the right mode? Oh, I don't have the right mode. Okay, so cos of 1.4 is 1.7. So 0.17. Okay, so that's 0.17. I'm going to zoom in a bit. That's 0.17 along the horizontal. That's 1. And I'm going to do sine of 1.4. and I'm going to get 0.98. Okay, so that means that if this length is 1, the vertical length is 0.98. So the sine value is 0.98. Okay, so I have my x and y coordinate, but that's not the point I want. I want it out here. So what I'm going to do is I'm going to use a unit circle as a unit rate. I'm just going to say that this position on the bigger circle is just 3 times farther away. It's going to be 3 cosine of 1.4. So if I go 1.7 times 3, sorry, 0.17 times 3 is going to be 0.51. Okay, so that's going to be the horizontal position. That's going to be about 0.51. And my vertical position is going to be 3 sine of 1.4. So my sine 0.98 times 3 is going to give us about 2.94. So the vertical position of that green point there is about 2.9, which makes sense because that's going to be 3 up there. That's just a little bit below.